Hello, it's Mr. Ricketts here, and we're doing more with relative density. This time, 3D to 2D transfer with Alouds. I know we've been talking about density and sinking and floating, so I just want to make sure that we're working with the same terminology. So let's take a quick review of our picture vocabulary. You ready? Good. First, we're talking about matter. Matter is anything that has mass and takes up space. Then we're also talking about mass when we talk about density, the amount of matter in something, usually measured in grams. So when you look at this picture, you can see that here we have matter and something in matter, mass and matter. So here we have density, how much mass a substance has in a given space. That's what density looks like. You see the two boxes, and they're little balls in the boxes. One has a lot, one has few. That's what we're talking about with density. But we also need to look at it in terms of sinking and floating and using that sinking and floating vocabulary with our density definition. So to sink means to drop below the surface level in a liquid. You can see here in the picture that part of the ship, like the Titanic, is sinking. It's below the surface of the water. Here in this picture, we're talking about floating, and that's to stay on the surface or above the liquid without expending any energy. So here we have these floatable balls at a pool, and they're like beach balls, and they're floating on top of the water, not underneath. So how does that relate to more dense and less dense? So more dense, you can see by the red arrows going down, means to drop below the surface level in a liquid, to sink, because it has more mass per volume. And you see that I've circled the box over here that has more balls in it. Well, let's look at dense. Density, you see the blue arrows up, so that means above. To stay on the surface of a liquid without expending energy. Float, less mass per volume, and I circled the box that has less balls in it. Okay, so we have sink and float and more dense and less dense. Let's take a look at them together. So on this side, I have, on my left-hand side, I have the words float and sink, with float on the top with the blue arrows pointing up, and sink on the bottom with the red arrows pointing down. Let's come over here to the right-hand side. I want to show you that less dense, you see the word float in it, because I want you to equate or put together those two terms. Less dense, float, less balls in there in the box. And then with the same color coding, I put more dense to drop below the surface. And I actually put the word sink in there in red and circled the balls with the more balls in it, the box with the more balls in it. So you can see more balls, more dense, sink. Now that we've looked at our terminology, let's go back and do some more think alouds. Now it's time for a little 3D hands-on on relative density. Relative density addition coming up. Do a little relative density math. Here we go. I have some water. And it's kind of dark. Let me lighten it up. I have some water here. And I'm going to pour some oil in this container of water. Now, what do you think the oil is going to do? Let's make a prediction. How many of you think the oil is going to float on top of the water? How many of you think they're going to change places and the oil is going to go to the bottom and the water to the top? Let's find out. Take my oil,
Slowly pour it. Slowly pour it. Slowly pour it. What happens? The oil rises to the top. It floats on top of the water. Now let's use our density words. You know Ms. Ricketts likes to use our new vocabulary. Which box would represent the oil? This box, number 1, or this box, number 2? I'll give you some think time. This box, number 1, represents the oil because it's floating on top of the water. We think in our mind that because oil is thicker than water, it's heavier. But for its size, it's not. It's floating on top of the water. Box B or 2 would be the water. This will be the oil. Oil and water. So here's my first container. The oil is less dense compared to the water. The water is more dense compared to the oil. So let's do something else. I have my oil. I'll pour it in. I'll put a ping pong ball in here. What do you think is going to happen once I pour the ping pong ball in the oil? Now I have a solid and a liquid, and I'm comparing the densities of the two. Relative density, comparing the two. I'll give you some think time so you could think of what's going to happen once I put the ping pong ball in the oil. You have a prediction? Ready? Drum roll, please. It floats. The ping pong ball floats on top of the oil. Now let's use our density. The ping pong ball would be the top one. Oil will be the bottom one in this instance. Let me move this out the way. Less dense, more dense. So the ping pong ball has less density compared to the oil. The oil has a greater density compared to the ping pong ball. But let's take it a step further, shall we? Container number 1 plus container number 2 will give us container number 3. What's going to happen when I pour these 2 containers into this container? Hopefully I don't overflow the oil. What do you think is going to happen? Are they all going to be mixed up? I don't think so, since they're not mixed up here. Which substance will be on the bottom? Which substance will be in the middle? And which substance will be on the top? I have 3 objects here. The water, the oil, and the ping pong ball. Make a prediction to think about what's going to be on the bottom and have the greatest density. What's going to be on the top and have the least density. Let's find out. Ready? I'm adding this one in here. No change. Now let's add this in here. What's happening? What do you see? I see water on the bottom. I see oil separating from water in the middle, and I see the ping pong ball at the top. Did you come up with that? Was your prediction right or wrong? Let's look at it. The ping pong ball was on top of the oil. It still is. The oil was on top of the water. It still is. So when we added these two cups together, we got this one. The ping pong ball has the least density, the water has the greatest density, and the oil has the middle density. Isn't that interesting? Relative density math. We'll be back.
Hello, everybody. Miss Ricketts here, and I know we've been working on density for a while and relative density, but I would like to go from 3D to 2D. We've been doing a lot of hands-on, but how do we translate and transfer that knowledge from hands-on into actually doing a pencil and paper question? And that's what I'm going to work with you on today. And they're called Think Alouds, so that you can see my thinking. I'm going to think aloud. You got that right. So let's start with the first problem, because this is really fun. It's a 2D Think Aloud relative density addition. So I have these two beakers. I have beaker number 1. It has plus beaker number 2. Is going to give me what's in beaker number 3. But there's a big question mark in beaker number 3 because I don't know what it's going to look like. And I've got to figure out what beaker 3 is going to look like. So the first thing I do is this. Let's label our densities. And I've done it right here. I have the water is more dense compared to the oil. And so it sinks. And I have the oil is less dense than the water because it floats on top of the water. So we labeled our beaker number 1. Let's go to beaker number 2. We have oil and a cork. And the oil's at the bottom, it sinks. So it's more dense compared to the cork, it floats. So the cork has less density or is less dense compared to the oil. Label your beakers by density. You got it? Good. Let's move on. The next thing I'm going to do is color code. Actually, I'm an artist. I'm an artiste, and I'm sensitive about my work. And I love to color. But this is how I color in PowerPoint. I label beaker 1 water blue, and I have the oil on top of it, which is yellow. And I still have my labels still going on. The water is more dense compared to the oil. Then let's look at beaker number 2. I'm using the same color from beaker number 1 for the oil that I am for beaker number 2. So the same substances, no matter what beaker they're in, gets the same color. So I colored it yellow, and the cork, which is less dense, is red. Color coding. We label number 1, we color code number 2. So let's move on. Now that I've color coded and I've labeled everything, let's match colors, thus matching the density. Matching the colors, matching the densities. So here I go. I'm going to take my beaker number 2 and put it with beaker number 1. What do you mean? I'm matching up the colors. Beaker number 1, beaker number 2, oil with oil. There's no water in beaker number 2, so I can't match water with anything. So if I were to put this on top of it, it would look like this. It's not perfect, but you get the idea, right? Let's go on to the next slide and see if it looks any better. Here we go. Matching the densities. I made them just a little smaller. Oh, here it is. Matching the densities, and I made them just a little smaller so it kind of fit better so you could see it. You kind of get the gist of it. Now with this, and I have it already here, I'm going to come and go back and get my Beaker number 3. Let's get number 3. Cut and paste. Move it on down to the slide. Here we go. Did it work? Hey, it worked. So let's just transfer what we have. You ready? What's at the bottom? The water. It's going to stay that way since we're matching up the colors. So here we go. Let me ungroup and get this together. There we go. Water right here. The bigger beaker, so I'm going to make it a little smaller. Send it to the back so I can do my work. There we go. Make my color even. It's not perfect, but you get it, right? Good. Then what's the next color? Yellow, and that represents the oil. So I'm going to come here, get my oil, put it right down here. Let's see, we got, oh, it worked. Surprise, surprise. And since I have this oil too, I'm going to ungroup it, pick up that oil, and spread it out. So this is a bigger beaker. There we go. Let's make it look nice. Then what's next? I'm going to get the cork. Cork's up there somewhere. We're going to find it. Move out the way. There we go. We got the cork. Uh-oh. No, we didn't. Here we go. We got our colors and we just matched it. What are we going to do next? Let's go back and label everything that we've already done. So here's beaker 1 with everything, beaker 2 with everything labeled. Here's beaker 3 with the water at the bottom, the cork on the top, and the oil in the middle. Now we've set it in terms of top, middle, and bottom. Let's go back and reinsert our definitions in our vocabulary. The water, which is sinking, has the greatest density. It's on the bottom. The cork, which is at the top, has the least density and it's floating on top of the oil. The oil has the middle density because it's in between the cork and the water. You have just done relative density addition, and all you had to do was be an artist and color and match. There you have it. Now it's time for a little 3D hands-on on relative density. Relative density addition coming up.
Are you ready? Hey, we're back. Let's do some more relative density math. You ready? Here we go. I have a container. I have some water. It's red. Pouring it in. If I pour some oil in here, what's gonna happen? Let's see if we can make a prediction based on what we've already done. That's right. The oil will what? It will float on top of the water. It has a what? It has a what? The oil has what? It has less density, less things. I'm trying to wait for you to hear it, but let me not do that. Let me do this. Put more water in here and put another solid. But this solid is a golf ball. What's going to happen when I put the golf ball in the water? Oops. It sank to the bottom. Can you see it? It's all the way at the bottom. Okay. That's my first thing. Now, let's put some more water in here. Now let's put some oil in here. What's going to happen? The oil is going to float on top of the water. That's right, because oil has less density compared to the water. So here we go. Can we see the two things? water with a golf ball, and oil and water. In this container, which object has the greater density, the water or the golf ball? The golf ball. Why? Because it's at the bottom. Maybe I should put some more water in it just so you could see that it's at the bottom. There you go. Water has less density compared to the golf ball. The golf ball has more density compared to the water because it's on the bottom. Let's do this container. Oil and water. Oil has less density compared to the water. Water has a greater density compared to the oil because the water is on the bottom. I know we always think that the oil is going to be heavier because it's thicker, but that's not what we're looking at. We're not looking at how thick it is. We're looking at how many particles are stuffed in there. The oil has less particles for the same amount of space compared to the water. Now, let's do the addition. You ready? I'm ready. This container with the golf ball and water plus this container with a water oil will put in this container. What do you think will happen? What do you think it will look like? Which substance or object will have the greatest density and why? Which substance or object will have the least density and why? What will float? What will sink? You have some think time? Let's try it. I'm putting the water and golf ball in here. Nothing do. Now, drum roll, please. Is the water going to be on the top or is the oil? Let's find out. Can't pour any more in, it's going to spill. The oil is on the top. The water is underneath the oil, so it has a greater density than oil, but the golf ball has the greatest density because it's on the bottom. Relative density math. It's fantastic.
Hello, we're back again. We're doing some more Think Alouds, and I think you got the gist of it. I really do. So let's go ahead and do another one for fun, and it's really a lot of fun once you get the secret, the hang of it. So let's do another Think Aloud where you could see and hear my thinking aloud. We're going to be doing another 2D Think Aloud relative density addition. And we have our 3 beakers here. In the first beaker, we have oil and water. In the second beaker, we have water and a metal bolt. And we're supposed to add these 2 beakers and see what we get for beaker number 3. So let's remember how we went about it the first time around. The first thing we did was we labeled our beakers by density. So let's look at beaker number 1. The water is at the bottom, it's sinking, so it's more dense compared to the oil. Or another way of saying it is that the oil is floating on top of the water and it's less dense. Let's look at beaker number 2. The bolt has a greater density because it's sinking in the water, and the water compared to the bolt is actually floating on top of the bolt. It's less dense. So we've just labeled and discussed our densities in our 2 beakers. Now what's our next step? Color coding. Everybody's an artist. The world's an artist. So let's look at our color coding. I color coded my water blue and the oil yellow. Now I'm going to stay with the same colors for the same substances or objects. So in beaker number 2, water is still blue, but the bolt is red. Now the densities are still there, but we just added the color coding. Next step. Matchy, matchy, matchy. Let's match the colors and match the densities. Now here, let me see. I think I've grouped everything, so let's see if it works. Oh, no, didn't group everything. There, I did over here. So I'm going to take beaker number 1 and add it to beaker number 2 and see what I get. Let's match, and I have to match blue with blue, yellow with the yellow. There's no yellow, so I can't match it. There's no red, so I can't match it. So I'm matching my blues with my blues. Here we go. Beaker 1 with beaker 2. I have the red stays the same, the blue is together, and the oil is on top. So when I match blue with blue, that gives me my density tower. That's what it looks like when I pour it into beaker number 3. So let's take a look at what it looks like when I have it in beaker number 3. I'm going to take it. Let me see if it's all together. I'm going to take my blue and let me ungroup it. Let me ungroup everything so it works and I can move it around easier. I'm going to take my water. Thought I ungrouped it. Let's try it again. I'm going to ungroup it. Good. I'm going to take my water over here in my big beaker, my little beaker, and put it in my big beaker. And I'm going to take my water from over here, my oil from over here, and that's on top. Correct? But here, and make sure I've ungrouped it, I've got to make sure that I take my water. So I'm going to have to lift this up a little bit and add my water to it. So everything stays the same. I'm adding blue to blue. Then, of course, I've got to move my bolt over here. And it's going to be on the bottom. See, this picture looks like the picture that we just did on slide number 5. Exact same thing. Exact same thing. So let's talk about it and label everything. We have the bolt right here. It has the greatest density. It's at the bottom. It's sinking. Then we have our water. Let's move this over here. And then what's floating on top of the water? The oil. That has the least density because it's floating on top of the water. Here we go. So we have it. So if you ask me to add beaker number 1 to beaker number 2, this is what beaker number 3 would look like. The bolt with the greatest density sinking at the bottom in the water, the oil floating on top of the water with the least amount of density. And we use our vocabulary terms, putting it all together. 3D to 2D. It's a good thing. World's your laboratory. Now we're back. We've been working with HandsOn, and then we've been switching to 2D, 3D to 2D, 2D to 3D transfer. We're going to do some more 2D transfer with another Think Aloud to make sure that we have the hang of this. So here's our 2D Think Aloud relative density addition, and we have, instead of beakers, graduated cylinders. And the first one we have corn oil with the water with a greater density compared to the corn oil. In the second container, we have a dish soap. The dish soap's on the bottom, but the water's on the top. So the dish soap has a greater density compared to the water. So we're going to add those two containers together and see what we come up with for the third container. What is it going to look like when I put container 1 and I add container 2 together and get container number 3? Next slide. To show my thinking, I'm always going to color code it. That's the best way I can do it. So over here, I have water. I'm going to make it blue. And corn oil yellow. That's my first graduated cylinder. Then I'm going to come over here and I'm going to use the same color for water that I used in the first one. Water over here, blue, and dish soap, our new element is red. So we did our color coding. That's how I think. Then I'm going to come over here and I'm going to match. Everyone say match. I didn't hear you. And I'm going to match color to color. Can I match the water to the corn oil? No, because it's yellow and blue. Can I match water to water? Yes, I can. When I match them together, it gives me what this third big graduated cylinder is going to look like. Dish soap, then water, then corn oil. Let's go to next one and put it together. So we matched it, right? So what's on the bottom with the greatest density? The red one. That is the dish soap. Let's put it over here. Very good. What's next? Water. Put my water here. Add some more water over here. Water is next. Then my corn oil is at the top. So when I add my two graduated cylinders together, this is what I get. A density column where dish soap has the greatest density, corn oil has the least density, and water's in the middle, too. That's how you do the think aloud. I hope you were able to see my thinking.